Hey guys, so here we are, new unit, and we're going to go over 8.1b today and talk about Intro to Parabolas. So these are the questions based on the video that you watched 2 posts ago. So if you want to follow along with your work, you should open up your 8.1b post so that you can see what you've answered. You should have been able to get your results when you took this form yesterday. All right, so for which parabolas open up in number 1? Pretty basic here, whoops. So this one and this one. Remember, if you have a parabola that opens down, that's a parabola that's been reflected. That's what we learned in the last unit. So knowing whether a parabola opens up or opens down kind of helps us with a lot of things with parabolas. It helps us to know if we're talking about a situation with a maximum or a minimum, or if the equation has a negative sign out in front or not. But 2 parabolas that open up, you had to make sure you selected both of those. All right, so which green line shows the axis of symmetry for this parabola? So when we look at the axis of symmetry, remember that's going to divide the graph in half so that both sides are mirror images. We're talking about choice A in this question. So for the next one, we talk about the vertex of this parabola. Remember, we talked about in the last chapter, the vertex is the place where the graph changes direction. So when I look, my vertex is right there. That is the point 1.5, comma, negative 3.5. So that is the choice that you selected. This graph opens up, so this point here is a minimum vertex point. Okay, exactly 1 x-intercepts. You've got 3 choices for parabolas. You can have a parabola that crosses the graph 2 times. You can have a parabola that crosses the x-axis. You can have a parabola that doesn't cross at all. Or you can have a parabola, I wanted it to cross just once. My pen doesn't want to do that. That just touches and goes back up. So you can have 2 x-intercepts, no x-intercepts, or 1 x-intercept. We want the picture with exactly 1. That's this one. All right, so which graph shows a parabola whose x-intercepts are at... what is going on there? There is a typo there. I will fix that on yours so that you guys don't see that. All right, so we need the parabola who has x-intercepts at negative 3 and 5 and whose minimum value is negative 4. So when we look at this graph here doesn't have x-intercepts at negative 3 and 5. So it's definitely not that one. This one looks like it does have negative 3 and 5, and also minimum point is 4, so it could be that one. That's definitely not this one. It doesn't cross the x-axis where we need it to, so there's our answer. All right, so next it says, if a parabola intersects the x-axis at negative 3 and 9, what is the x-coordinate of the vertex? So in one part of the video, it talked about, we have this parabola, and every parabola is symmetric. So you're going to have this parabola, and it's going to have this line of symmetry, or axis of symmetry. You'll hear it referred to as both of those. And that line is going to divide this in half. So you have an x-intercept here at 3 and an x-intercept here at 9. Your vertex has to be right in the middle of those 2 x-intercepts. So if the x values for the x-intercepts are 3 and 9, we need to go right in the middle of 3 and 9. So we can actually average those, and you would get 6. So the x-intercept, or the vertex, has an x-coordinate of 6. So you know it's going to be 6 comma something. Okay? All right, let's see the next one. Go to the next one? Yeah. So Simon has a certain length of fencing, and he's going to use it to make a enclose a rectangular area. So the function A models the rectangle's area as a function of the width. So you've got your width on the x-axis, and the area is up there on the y-axis. So we need to figure out which choice down here makes most sense based on the graph that we're given. Notice a couple of things. On the x-axis, the width is getting larger. On the y-axis, the area is getting larger until it reaches the maximum point, and then it's going to come back down. So we want to decide which question down here makes the most sense. So it says greater width relates to greater area as long as the width is less than 10. So 10 is kind of important here. Let's look at it. That's where your axis of symmetry is. So the graph's divided in half at x equals 10. So when we talk about the graph, the area is going to increase until it reaches this maximum point up here. And when it reaches that maximum point up there at the vertex, it will then start to decrease. So if we think about what's happening in this question, we can say that the larger the width, the larger the area, as long as we're talking about this side of the graph. So I think the answer here is going to be number 1, or the first choice, I should say. If we look at the other choices, when the width is more than 10 meters in the second one, that doesn't make sense, because when we look at the other side of the graph, the area is decreasing. To get the greatest area, the width should be 10 meters. That one's also true. The greatest area does happen at 10. So you'll have 2 choices here. The other thing, that the last one there, the width should be 20. If you look where the width is 20 down here, that makes no sense at all to have the greatest area. The area when the width is 20 is 0. All right, next one. So Sarah kicked a ball in the air. Here's the function. X-axis is time, y-axis is height. So when we look at our choices here, the ball moved upwards for about 3.5 seconds. I would say that is not accurate. So when we look at this, you've got your line of symmetry somewhere in there. So the ball is moving up on this side and down on this side. So you want to consider this almost like 2 parts of the flight of the ball. You've got where the height is increasing, you have where the height is decreasing. So, not the first choice. The ball moved upwards for about 1.75 seconds. That's true. So that one's good. And then the ball hit the ground at about 3.5 seconds. That's right down here. That's also true. So we got 2 things going on there. That last choice, the ball hit the ground at about 1.75 seconds. That's not true. That's where the ball's at the highest flight. All right, the next one. The function G models the number of mosquitoes in a certain area as a function of the rainfall. So you'll notice here we've got your axis of symmetry is right here at 2. So the maximum amount of mosquitoes here is going to happen here. When you have 2 centimeters of rainfall, there will be 4 million mosquitoes. So that's what this point up here represents. So let's take a look at our choices. The largest possible number of mosquitoes is 2 million. No, we just said it's going to be 4 million. That's up at the top there. The largest possible number of mosquitoes is 4 million. More rainfall always relates to less mosquitoes. That's not true, because when you look at the second half of the graph over here, the rainfall is increasing, but the number of mosquitoes is decreasing. And then the last choice, more rainfall relates to less mosquitoes as long as the rainfall is less than 2 centimeters. Now, that's not going to be true either, because when we look at this side of the graph, as we approach 2, we're getting more mosquitoes. So we just have one choice there. All right, last question. A certain company's main source of income is a mobile app. The function, why did it do 3 H's there? I'll fix that on yours. So this function models the company's profit in dollars, millions of dollars, as a function of the price they charge. So you'll notice that the price is getting larger for the app, and then their profit reaches a maximum and then comes back down. So let's take a look at our choices here. Greater app price always relates to greater profit. Nope. So when we reach our maximum here and the app price is starting to increase, the price is dropping, or the profit is dropping. Greater app price relates to greater profit as long as the app's price is more than about $7.77. So we're talking about over here on this side of the graph, when the app price is greater than $7.77, and when that happens, you'll see that the profit is decreasing. So it's not that one. The largest possible profit that the company can make is about 40 million. That they're talking about the max point right there. So when I look at that, that's pretty close to 40 million. So I think that's a definite possibility here. So let's highlight that. And the last one, the largest profit they can make is 7 million. No, that's not true at all. So notice the highest profit that we have is 40 mil. All right, any questions? Post them below.